Hello and welcome to another episode of Math Time.
Today we'll be talking about exponents. What exactly will we be doing with them?
I think a simple introduction and some multiplication etc. should suffice.
Great! I'll start off by telling you what exponents are. Exponents are those small numbers you may see above in the top right corner of numbers or variables. Kind of like the one shown here. But what do they do, Matthew?
The little number in the top right corner of a variable or number is called an exponent. The number or variable that the exponent is on is called the base.
If the exponent is a 2, then we see that the number is squared. If the exponent is a 3, we see that the exponent is cubed.
We know that there can be an exponent that has bigger value than 3. We just use the term power of. If we have 3 to the power of 10, we say that is 3 to the 10. 3 to the power of 10. Or we can just say 3 times 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 3. I think I got them all.
Wow, that's a mouthful. So again to the question, what do exponents do?
Well, exponents are a way to shorten your multiplication. That's the whole point. Check out the graph. If we're multiplying a number with itself, we can make life easier and save time and energy, as well as our hands and paper, if the exponent is a large enough number.
Wow, these exponents sound pretty handy. So how do I use them?
Alright, using exponents is easy. You just write a small number next to a normal-sized one. You just have to know how to use them. That small number indicates how many times you multiply the big number by itself. For our example, we have 5 times 5 times 5.
So 5 times 5 times 5 can be rewritten as 5 cubed?
Exactly.
Really, the hardest part of this is remembering that 5 cubed is never the same as 5 times 3. So don't mix this up with multiplication.
So basically, the little number or exponent tells you how many times to multiply the base by itself.
Does that mean, since we're using multiplication, that 4 to the 10 is the same as 10 to the 4?
No.
Prove it.
Like we said before, it isn't the exact same thing as multiplying. It's only an easier way to write it out and easier to solve. If you want proof, here's proof. 4 to the power of 10 is equal to 4 times 4 times 4 times 4 times on and on. And that equals 1,048,576. And 10 to the power of 4, 10 times 10 times 10 times 10, equals 10,000. Those aren't equal.
Is there a way to add, subtract, multiply, and divide exponents?
Yes, there is. It's kind of complicated and sometimes confusing. We'll focus on multiplication and division for now.
Okay, so say we have the problem 10 cubed times 10 to the 5. Now this trick only works if we have two numbers with the same base.
Okay.
If we have two numbers with the same base that are being multiplied, we can just add the two exponents. 10 cubed times 10 to the 5 becomes 10 to the 8. To check, we can do 10 cubed equals 1,000 times 10 to the 5 equals 100,000 equals 10 to the 8, which is 100 million.
Wow, that was easy. What about dividing?
Same process. It only works if it has the same base. Let us use the example 11 to the 12 divided by 11 cubed.
Let me guess. Since we're dividing, you would subtract the exponents.
Yes, you're right.
So the answer is 11 times 9.
Now if you have 9 cubed to the power of 5, we can apply the same strategy.
It becomes 9 times 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 9.
Yes, an exponent to an exponent is the same as a base to the power of exponent 1 times exponent 2.
Now you see how easy exponents can be once you get the hang of it? So we'll be moving on to
scientific notation!
Perfect. Scientific notation is just moving the decimal point, really.
Well, that's pretty easy. We write out scientific notation like this.
Remember, this is the only time we use an x for multiplication.
Right. So if 10 is to the power of 4, then we just want to take the number 5 and move the decimal place 4 times.
Then, fill in zeros.
Think of it as a homeless guy.
Say what?
We'll take a look at this animation. You saw a homeless decimal point walking around along boxcars. Hey, go right! Okay, stop. Wow, That works well. But what about negative exponents? Easy. Go left.
Ah, I get it. That's pretty clever. I'm going to leave Aditya to playing with Mr. Hobo Decimal Point. Well, thank you for joining us on another episode of Math Time. I'm Matthew Daly saying for the rest of the Math Time team, never stop doing math.